Hey folks, okay, this is mostly just to kind of wrap up a whole bunch of the little bits and pieces that might come in handy in Lisp that we haven't really touched on. I'm not going to spend much time on any of them at all, just to kind of point out they exist and you can go explore and play with them when you get the chance. So, regular expressions are something that's obviously going to crop up a fair bit. When we start looking at analyzing Lisp code in Lisp again, then you can see how the idea of using regular expressions to kind of read in an element of code and figure out some meaning associated with it can come in handy. If you're going through and trying to do things like tokenize files, the regular expressions are going to come in fairly handy. So pretty normal syntax other than the backslashes. So SI is one of the packages that's available for Lisp, and there is a function in there called string match, where you give it a regular expression and you give it a string, and it tells you yes or no. Does that string match that pattern? So basically, what it'll do is see if it can find the pattern somewhere in the string. It'll tell you where the pattern starts, and it'll return a -1 if there's no match. So if the pattern matches right at the start of the string, it's a 0. If it starts matching in the next character, it's a 1, etc., etc., etc. Usual sort of idea for regular expressions, the caret and the dollar to match the start and the end of a string. You can wrap, pieces of a regular expression in parentheses to say, okay, well, I want to repeat this 1 or more times, 0 or more times, 0 or 1 times. So those are pretty traditional. You can use the square brackets to say any character in this set or in a range, and the caret again within that to flip that to say anything that's not in this set. The backslash is used for escaping, so if you've got special characters, you can throw that in. So for instance, if I actually want a square bracket to be in my list inside the square brackets, and the backslash and then the square bracket. In our regular strings, if we've just got a plain old text string, ignoring the regular expressions for a moment, to have a backslash in your regular old string, you need 2 backslashes. So that means that in our regular expressions, because it's using escapes for the backslash, you need a backslash for that first backslash and a backslash for the second backslash. So you wind up, if you want to match the pattern a single text backslash, then you wind up needing to put 4 of them in your pattern. So that does take a little bit of remembering. There is a requote string that's available for you. So you give it the string and it inserts the extra backslashes for you. So that is fairly handy and just something to keep in the back of your mind. If you start running into problems matching patterns with backslashes, that's probably what's going on. I mentioned the idea of packages a moment ago. It's similar to the idea of a namespace in C++. And so you can have, you can create a whole bunch of these things, and you can declare, you can declare pi, for instance, in a whole bunch of them with different values, and then just specify which one you want to use, or have a function named initialize in a whole bunch of these things and specify, I want to use the initialize from a specific package. So fairly conventional syntax. You specify the name of the package, 2 colons, and then the name of the thing that you're trying to access. If you want to use everything from a package, it's use package and then whatever the package's name is. There's a variable that you can look at to see which package you're using by default right now. So it's si : so si is clearly one of our packages, and then asterisk package asterisk. You can switch which package you want to use by using in package and the name of the new one. You can get a list of all the available packages. You can create a new package. So you make a package, give it a new name, and you can initialize it from an existing one. So you can say use the common Lisp package as sort of the starting point. So something to keep in mind. Timing, you can get the current time in a human-friendly format or in a clock time format. You can time how long something takes to run. You can pause programs with a sleep, so fairly conventional set of time manipulation functions. Random number generators. Again, usual idea, you have to seed your random number generator if you want the behavior to actually seem random. So make random state is the one to seed it and just pass it true as its parameter, and store that in the variable star random dash state star. And again, that's an existing variable. Then if you want to get an integer, you just use random n. If you want a random float, I believe that has to be 0 to 1. I'm going to have to go back and play with that one a sec. You can actually compile your Lisp code, so you can compile it into an executable, for instance. It does create pretty huge executables because it puts the interpreter in there pretty much. So in your Lisp code, don't have the hashbang line in it. Do declare a main routine using this syntax. And then in the interpreter, to go through and compile the file that's got this in it, then you go through and use compile file in the name of the file. You use the load. So this is the compile is going to create a .o file for you. Load the .o file, and then use a system save or save system to and give it an executable name. So again, it creates huge executables, but it is an option. During the run of a Lisp program, if you go through and create functions, you can compile them. So you can compile an existing function, you can compile a lambda function, you can load other compiled .o files. Actually, if you want to take a look at the assembly language that's associated with one of the compiled files, you can do that as well. Just give it the file name and disassemble. So there are a bunch of things you can do in terms of compilation to just play with efficiency. There's a bit of exception handling offered. So there's a catch and a throw. So you can throw something and you can try and catch it. So you create a catch block, kind of like a try block, where you're going to say, okay, well, let's catch errors that get thrown in this and come up with a throw to say, here's the problem. And it will go through and store the result of whatever was thrown. So not quite as powerful as exception handling in some languages, but there's something there. Gotos are supported in Lisp, so you can do a jump straight to a label someplace. So the limitation here is that you can jump to labels. You have to specify that this is within a tagbody block. So I'm saying that within this big block, I can jump around using go and then a label. So any place where you stick a label, you can jump to that spot. And you can jump to things like the labels in a block, for instance, if you've got blocks located in here. So you can jump around and use gotos. Usual drawbacks of using gotos in your code. What else? Oh, Dribble I was going to mention was if you're running an interactive Lisp session and you want to record it, you could use something like script from the command line, so run script and then go through and record everything that happens and exit afterwards. Or Dribble is set up, so Dribble and then whatever the name of the file is that's got your Lisp code, the name of the file you want to store this stuff in, and then whatever it is you're going to do, and again, it's going to record all of the input and all of the output, and just end it with a Dribble. So, just a bunch of miscellaneous bits and pieces that may or may not come in handy. Feel free to explore.